In this video, we're going to walk step by step through how to calculate the average illuminance in a room based on the lumen method or the zonal cavity calculation. This is page 179 in your textbook if you want to follow along. We learned in the last video that there are two different ways to calculate the illuminance in a room. One's the lumen method, one's the point-by-point method. The one we're using for this example is the lumen method, and therefore we're going to end up with a number for the average illuminance on a work surface in a room, a very specific room as determined by this example. So those calculations for illuminance, remember, can be done by hand, which is what we're doing right now. We're going to walk through it, or, and is more typical for professional lighting designers, they can be done using a lighting software package. So the first thing we're going to do here is take a look at this list of information that you need to collect and need to gather in order to end up with our number at the bottom of an average illuminance on the work surface. And this list I found on page 176 of your textbook if you want to go ahead and follow along with that. So in order to do these calculations, you need a lot of information to get to your final number. You need information about the room, its proportions. You need information about the luminaires and lamps that you're proposing to put in the room. You'll need to know where your work surface is, not specifically in the room, oh, it's against the left-hand wall. What you need to know is its height. And therefore, since you know the room proportions and the work surface proportion, you can find the distance between the work surface and the luminaire. Remember that that's called the mounting height. We need to know the reflectance value for ceilings, walls, and floors. Light reflects or bounces off of these surfaces, and we take that into account in this calculation. And once you have this basic information here about your room and your design, then you start crunching the numbers, and then we'll find the room cavity ratio. I'm going to walk you through each one of these. The coefficient of utilization, remember that. The light loss factor, which is going to include the lamp lumen depreciation and luminaire dirt depreciation. And finally, with all of these numbers and all of this data, you're going to be able to calculate the average illuminance on your work surface. So let's get started. For the next couple of slides, what you're going to see is on the left-hand side, this list, it's the same list from the last slide of information needed. What kind of information do you need to gather for your project? On the right-hand side, I've listed the information for example 8.1. Again, turn to page 179 in your textbook for this example. So the first piece of information we need is room proportions, and it's given to us as 30 feet by 30 feet with a 10-foot ceiling. The luminaires and lamps in the room, we're going to use the figure 8.4 spec sheet for the luminaires, and you can remember that this is a picture of that luminaire, or at least an illustration of it. For this particular location, they're not going to use the pendant mount as is shown here. They're going to select the surface mount. For lamps in those luminaires, the designer has chosen two F32 T8s in each luminaire. So each luminaire takes two of these fluorescent tubes. By the way, when I was looking at this, it occurred to me that maybe we hadn't discussed this, but F32T8. First of all, F is for fluorescent. because there are also LED tubes. 32 is for the watts. This fluorescent tube requires 32 watts of power. And T is for tube. And 8, the number 8 is how many eighths of an inch in diameter. Oh, I hope that didn't come out very poorly in my microphone here, but how many eighths? For 8, it is a 1-inch diameter because that is 8 eighths. So all in all, the F32T8 is a fluorescent tube that needs 32 watts of energy and is 1 inch in diameter. If you take a look at a catalog of a common fluorescent tube manufacturer, you can find that the initial lumens produced by this lamp is 2800. Why is it initial lumens? Remember the depreciation that happens over time and the degradation. And so we're interested in how much lumens it puts out as in the initial phase when it's a brand new lamp. And then we'll use the light loss factors to account for how it loses performance over time. So then we would use the room size and spacing criterion to estimate that you need 12 luminaires for this room. And we talked about spacing criterion last week, so you know that you can walk through that calculation and find out how many luminaires you should probably have for the room. Final piece of information you need, you're going to use 12 luminaires. There are 2 lamps per luminaire. That's 24 total lamps. Right here. Our work surfaces are going to be 30 inches above finished floor, 2 foot 6 inches above finished floor. And therefore, the distance between the work surfaces and the luminaires, remember that's called the mounting height in these calculations, is 5 foot 6 inches, so 5.5 feet. The reflectance values for the ceilings, walls, and floors are given to you in this problem as 80% for the ceilings, 50% for the walls, and 20% for the floors. In a real project, you could find these numbers by looking at the spec sheets of the materials you've chosen. So perhaps it's a carpeted floor. There's a reflectance value for that. So we got some basic information about the room and about the luminaires in it. Now we're going to start doing some calculations. And the first thing we're going to find is the room cavity ratio, or RCR. This is a way to take room proportions into account in your calculations. It uses the mounting height from the work surface, and then the RCR, or room cavity ratio, is used to find the coefficient of utilization. So the formula for RCR is 5 times the mounting height times the length plus the width. Okay, make sure you got it plus in addition right here. I was very confused for a while. I couldn't make these numbers turn out until I realized that that was indeed an addition right there. And then you take that piece and divide it by the area of the room, or the length times the width of the room. So for our project, our room cavity ratio is 5 times the mounting height of 7.5 feet times the length plus the width, which is 30 plus 30. And that whole piece is then divided by the room area of 30 times 30. Therefore, the room cavity ratio is 2.5 and we're going to round it to 3. Okay, so we got a number for the room cavity ratio. So what do we do with it? It turns out we need it to find the coefficient of utilization. Remember that the coefficient of utilization is the ratio or multiplying factor of initial lamp lumens, so the lumens that the lamp is putting out, to the lumens that make it to the work surface. It's going to depend on the specifics of the space and also on the lamp and luminaire. So the specifics of the space were all accounted for in the room cavity ratio. That's how we account for those in the CU, or coefficient of utilization. The rest of the factors, the lamp and the luminaire, this information is available from the luminaire manufacturer. So for this project, we're going to read it from the table given to us when we were given that photometric data in the textbook. And so here's the table right here. It's the coefficient of utilization. And so it is specific to the reflectances of the floor, ceiling, and wall. So floor reflectance, we're in the 0.2 or 20% category. And then in this 0.2 or 20% category, you can choose from a ceiling reflectance of 80%, 70%, or 50%. Well, we're going to choose the 80% section. In this 80%, you can choose a wall reflectance of 70, 50, 30, or 10. We want to be in the 50 range, because remember that number was given to us. And so this column right here is the one that applies to our project. Now we need to find the room cavity ratio, and those are the rows of this table. So room cavity ratio, 1, 2, 3, 4, 5, 6, and it continues. We're looking at a room cavity ratio of 3. And so you come over here in this column and this row and find that your coefficient of utilization is 46. Now, your textbook also has this 43 right here highlighted. As far as I can tell, that's a printing error. I don't know why. Okay, the next factor we need to take into account is our light loss factor. To find the light loss factor, we're going to consider the lamp lumen depreciation and also the luminaire dirt depreciation. So for the lamp lumen depreciation, or LLD, we're going to look at the specific lamp that we've chosen, which is the F32 T8 lamp. And you can use a standard factor that goes along with that particular lamp. In your textbook, they've given it to you. There's a table 8.1, and that number is 0.93. So 93% of the lumens, sorry, let's back it up. So at the end of this lamp's light, so at the end of this lamp's lifespan, it produces 93% of the lumens that it did at the beginning of its lifespan, and it's gone down 7%. Next, let's look at the LDD, which is, remember, is the loss of lumens due to dirt and dust. I've got the picture of that very dirty lamp there. And it's given to us that this is a clean space, and the lamps will be cleaned twice a year. And this particular luminaire is in maintenance category 3. All right, your book goes into more detail about these, so please go ahead and read through that all. But given those 3 factors, clean space, lamps cleaned twice a year, maintenance category 3 for this particular luminaire, We find out that our LDD, or luminaire dirt depreciation factor, is 0.92. So the light loss factor includes many different factors, but in this particular calculation, we are only going to consider those two depreciation factors, the LLD and the LDD. And to get your light loss factor, you're going to multiply those two other factors together. So we've got a 0.93 multiplied by a 0.92, and we get a 0.85. Remember what that means. You're going to produce a certain amount of light at the very beginning of your lamp and luminaire's lifespan. By the end of its lifespan, you are only going to get 0.85 of that light output. So 85%. So it's going to go down by 15% over the lifespan of that lamp and luminaire. All right, guys, we're in the home stretch now. We've got a lot of information about our project. Let's put it all together and find out how many foot candles we are actually receiving on our work surface in this room. And the formula for that is the number of lamps in the room multiplied by the initial lamp lumens multiplied by the light loss factor and the coefficient of utilization. And take all of that and divide it by the area of the room. All right, so here we go. For example 8.1, how many lamps did we have? We had 24. What were the initial lamp lumens? They were 2,800. The light loss factor was 0.85 or 85%. And the coefficient of utilization was 46% or 0.46. Let's put this all together. Here we go. 24 times 2,800 times 0.85 times 0.46. Divide all of that by the room area of 30 by 30. You end up with a grand finale of 29.2 foot candles delivered to the work surface or to the desk in that room. Or, and your textbook rounds this to about 30 foot candles in your room. All right, we got 30 foot candles. Ooh, I don't know. Is that enough? Is that what we want in this room? Okay, we'll reach all the way back into last week when we talked about how to set a target illuminance level for a particular task or a particular use or function of a room. And here are the IES, Illumination Engineering Society, recommended illuminance levels for different room types. I think I forgot to mention it way back in the beginning of this video, but your example for, what is that, example 8.1 in your textbook specifies that it's a classroom. So in a classroom, we would like to have somewhere between 30 and 50 foot candles. Our almost 29, oh, so we're just at the bottom of that level. But also remember that the range, one of the factors you need to take into account in the range is the age of your client or your target audience. So perhaps this is an elementary school classroom and we have some very young clients in there. Using the bottom end of the range would be perfectly acceptable. And therefore, ta-da! Your proposed design with 12 luminaires of that specific type, and that mounting height and that specific lamp in there meets your target illuminance levels, you can check that box and feel good about your design. All right, everybody. So we walked step by step through the example in your textbook. Now, for the activity this week, or for the assignment, excuse me, I've asked you to turn to page, excuse me. It is page 184 in your textbook, and there is a second uh, problem for you to work through. Kind of follow the same steps that we just did and see if you can find the illuminance at the work level of that room.